Welcome to Unit 4, Nth Roots. Let's get started. We've been working with square roots. So the square root of a number, square root of 16, is 4. And that's because 4 times 4 is 16. Now we're going to be working with nth roots, which is the 4th root of something, or the 5th root, or the 6th root, and so forth. So the 4th root of 16 is 2. And that's because 2 times 2 times 2 times 2 would equal 16. So that's 4 of the 2's. So the 4th root of 16 is 2. When you look here at the square root of 3 equals 3 to the 1/2 power, can you identify the pattern, how this is equal to this? Take a minute to pause the video and see if you can identify the pattern. The pattern here is that whatever is under the exponent stays as the base. You can see the 3 and the 3, the x and the x to the 5th, and is x to the 5th still. X to the cubed, or x to the 3, is x to the 3. And since this is kind of like a 1, that's why there's a 1 here. And then whatever the nth root is what becomes the denominator in this fraction. So x to the 5th, and then the 4th root, and that's why there's a 4 under here as the denominator. X, here's the x with the 1, and then the 3rd root, and that's what goes here on the denominator. So the 3rd root of x is x to the 1/3, to x to the 1/3. So if we had the 9th root of x squared, then that is equal to x and then 2/9. So x to the 2/9. That's where the 2 came from, and then the 9th root became the denominator here. So let's talk about the two forms that they were in. At first, before we changed them, they were in a radical form with the nth root. And this n, like we said, is the nth root, or the index. And then here, right here, that number or the letter, whatever it is, the variable, is called the radicand. And it's raised to this power. Now remember, we said that this equals the base to that fraction, to the power of that fraction. And so this is your rational form. This is still the base, or this is your radicand that became your base. And you can see here the m over n is your exponent. So let's do these together. We'll write, this is your rational form. It's got the base with the exponent, and we want to write them in radical form. So go ahead and do this on your paper. We've got 3 to the 1/6 power, and so remember that denominator here becomes the nth root. So the 6th root of 3 to the power of this 1. We've got here the 8 to the 1/5. And that denominator in the exponent becomes the root, the nth root. So the 5th root of 8 to the power of 1. Over here we got on the denominator, so the 3rd root. And then remember, this is what goes underneath, 12 squared. And then this last one, you've got the square root of x to the power of 1. You could also just write it like that. You don't have to put the 2 if you don't want to. So now let's go ahead and go the other way. Now we've got something in the radical form, and let's write it in the rational form. That means the base with the exponent. So remember that that nth root is the denominator in your exponent, and in this case our nth root is, we got a square root, that's 2, so that's going to be the denominator in our exponent. Whatever's underneath this, the root, or the radicand, that's what your base is, so that becomes 51. And then whatever this power is, in this case it's just 1. So the square root of 51 becomes 51 to the 1/2 power. Over here, the third root, or the cubed root of 37, is going to be 37, 1 over 3. The fourth root of 15 cubed becomes 15 to the 3/4 power. And then the last one, we've got some variables in here, but we're still going to do it the same way. We're just going to take each one piece by piece. And we have 6 to the 1/3 power, x to the 1/3 power, and y to the 2/3 power. And remember that this nth root is the denominator in your exponent. And then whatever it's raised to in here, 6 to the 1, x to the 1, and y squared. That's how you get your answer. And it's okay to leave it just like this. That's all for today. Thanks for watching and see you soon.